thing we have to know, right? Because it's not realistic. If you're poor, you just have less to. I mean, you have to. I mean, make sure that you can satisfy basic consumption needs. When you're very rich, I mean, Elon Musk certainly saves more than some person selling food on the streets of Ho Chi Minh City, right? Because he's just more safe. Now, does this mean that this is a bad model? No, but it means that if we want to move it closer to reality, we have to modify it, right? Second thing, what happens if beta goes up? Now, usually what I tell my students in Mainz, you might want to take a derivative, but you can also do it with eyeballing, right? If beta goes up, beta to the power of minus over sigma goes down. And if beta to the power of minus over sigma goes down, the whole thing goes up. So if beta goes up, S1 goes up. So more patient people save more. Right? So beta is, so note that if beta is high, you give more weight to the future. So you're more patient. If beta is close to 0, then you're giving less weight to the future. You're someone who's very impatient. Now, let me come to the most fascinating part. What is the role of 1 plus r for savings? Well, you see that 1 plus r has sigma minus 1 over sigma here. Now, if sigma is greater than 1, then sigma minus 1 is greater than 0. And so if 1 plus r goes up, you're dividing by something that is larger, and so savings goes down. If sigma is greater than 1, but savings goes up if sigma is smaller than 1, and no effect on savings if sigma is equal to 1. Now, this is something really surprising. Now, what is sigma? Recall 1 over sigma is the intertemporal elasticity of substitution. So if the intertemporal elasticity of substitution is smaller than 1, this is the case. That is, the IAS is greater than 1. This is the case if the IAS equals 1. This is the case. So the reaction of savings on changes in the interest rate crucially depends on the intertemporal elasticity of substitution. The intertemporal elasticity of substitution that I derived on the second day of this course, last Wednesday, so it's in the notes. The intertemporal elasticity of substitution is of crucial importance for the reaction of savings to the interest rate changes. You might actually have no effect at all. You might have something that we would expect, namely that savings goes up when the interest rate goes up, because then you have 1 plus r to the power of something that's negative. So if 1 plus r goes up, then this goes down, and so the whole ratio goes up. But you have also that possibility that people actually save less when the interest rate goes up, which is counterintuitive. Most people would say, why the heck? Now, what is the intuition behind that result? And the nice thing about economics is most formal results have some intuition, right? Unlike in physics or chemistry, right? Now, the intuition that you told me was referring to the so-called substitution effect. And it's absolutely sound, right? You say, if the interest rate goes up, then I have a higher incentive to shift consumption away from the present into the future. So I have a higher incentive to save more. Now there's another argument, and that is when the interest rate goes up, I don't have to save that much to have a decent standard of living. Suppose that on every dollar that you save, you get a 500% interest rate, real, right? That means every dollar you save will be turned into, what would be, $6 in the future. Then your reaction might be, I don't have to save that much to afford to have high consumption in the future. And that's exactly the second thing. And that goes against the substitution effect. Now let me draw a picture. And you've seen such things before. So suppose this is first period consumption, this second period consumption. Suppose that, that's not a good start. Suppose that this is your first period income. The slope of this is 1 plus r. Should be. You will know why I have to mess around with that a little bit when you see where I'm heading. Yeah, that's better. Now this is your first period consumption, this is your second period consumption. Now what happens in that picture when the interest rate goes up? Given that the slope is 1 plus r, what happens to that budget constraint if 1 plus r goes up? So now please let me tell you what that means. It means this is the budget constraint in the two-period model. If you consume all your income in the first period, you have nothing to save, and you consume 0 in the second period. This would be a situation where you save all your income, so you have high consumption in the second period. This line is feasible combinations, right? Now you try to reach the highest indifference curve given your budget constraint, and this is just a graphical representation of that solution. Now what happens if the interest rate goes up? Well, this line becomes steeper. Okay, right? So this line, so if the interest rate goes up, this line becomes steeper. Now the question is, where's the new point, the new optimality point? Well, it might be here. Now, interestingly, this is here. C1 star new is greater than C1 star old, right? This so as 1 goes down, if 1 plus r goes up. What's going on here? Well, what's going on here is that we have to split the total effect into two effects. And this is basic micro, into a so-called substitution effect. The substitution effect says you move to a point on the old if difference curve where the slope is the same as the new interest rate. And that moves you in this leftward direction, right? So the substitution effect says that savings goes up. But then you have another effect, which is the income effect. So that's the substitution effect. And then you have an income effect, and the income effect says savings goes down. And the total effect